Today we are talking about tangent lines and what kind of effect those have when paired with secant lines in a circle. So we'll start off by defining what is a tangent line. A tangent line is a line which only intersects a circle at a single point. That point is known as the point of tangency. I didn't spell that right. Tangent C, I think. I could be wrong. That might still be spelled wrong. Okay, so here in this picture we have a line. That line is intersecting circle C. Let's call this circle C. Call that point A, and we'll just put another point here on the line B so that we can say line AB is tangent to circle C. That means it only intersects the circle at a single point, that point being A. So we'd say A is the point of tangency. And again, I could be spelling that wrong. I guess I can check. Probably would be a good idea to make sure I'm spelling that wrong before I put it on. It seems to be okay, at least according to my spell check. All right, close enough. Whatever. All right, so it's interesting to note that tangent is one of those things that has a couple of different meanings in mathematics. So this is not the same as tangent, the trig function that we discussed earlier in the year. Okay, this tangent line is an entirely different idea than tangent, the trig function. Okay, so that line AB only intersects circle C at one point. That point is point A. Okay, that is a tangent line. Grab a screenshot if you want one. We're going to move on to the next screen. Okay, so tangent lines are going to come into play with secant lines in the form of a theorem, the secant tangent intersect theorem. And this is another example, just like the secant intersection theorem that we talked about on Wednesday, that it's really hard to put into words. Okay, it's a really simple idea that is really, really hard to put into words. Okay, if a secant line and a tangent line intersect outside of a circle, which is what we see in the picture below, then the distance from the point of intersection to the point of tangency squared is equal to the product of the distances from the point of intersection to the circle on the secant line. So here's the deal, okay? We have three lengths in this picture. We have the distance from the point of intersection to the first intersection on the secant line with the circle. We have the length of the chord inside the circle that's part of the secant line. We'll call that B. And we have the distance from the point of intersection to the point of tangency. We'll call that C. Okay? So C, that is the length of the tangent line segment. And A plus B would be the length of the secant line segment. Okay? Now this is a very similar rule to the one we discussed on Wednesday. In fact, one side of the equation is exactly the same as the one we discussed on Wednesday, because the portion of the secant line that is outside of the circle times the entire length of the secant line is equal to the length of the tangent portion times itself. So instead of A times A plus B equals C times C plus D, now we have A times A plus B equals C times C, or C squared. Okay, so it's still the same rule, more or less. The part on the outside times the entire length equals the part on the outside times the entire length, because on the tangent line, the part on the outside is the entire length. Okay? So that's the equation we're going to use every single time. Okay? Where we basically have the two sides of the equation here. One side is going to be the secant side, and one side is going to be the tangent side. Okay? That's on the secant side, that is outside part times the entire length. And on the tangent side, we just square the length. If you have any questions about that, drop them in chat. Otherwise, we're going to move on to an example. And I've got, I believe, 4 examples that we're going to go through rather quickly here. And then we will move on. Okay. So, find the value of x in the figure below. Now, this is the exact same picture. I've just put some numbers in there. Okay. So remember that on the secant part, the part on the outside is A, the part on the inside is B. And then the x is going to be the length of our tangent in this case, so that's going to be our C. We have one equation, A times A plus B equals C squared. So we plug in those numbers. We have 2 times 2 plus 30 equals x squared. From there, we're just going to simplify this. We're going to solve for x. Okay, so we simplify the left side. 2 plus 30 is 32. 2 times 32 is 64. And then to get rid of the squared, we're going to take the square root of each side. It's almost as if somebody thought at some point it would be a good idea for you to memorize your perfect squares so that you would know that the square root of 64 is 8. Now, those of you in algebra are going, oh, plus or minus 8. Yes, technically plus or minus 8, but x is representing a distance in this problem, which means we don't care about the negative root. We only care about the positive root. Our answer here would be 8. Grab a screenshot if you want one. We're going to go on and do another example. There's basically 2 forms of this problem. This is form 1. Well, 2 forms we're going to discuss, 3 forms total. Okay, nobody's dropping any knowledge in the chat box, so we'll move on to the next example. Picture's changed a little bit, but not enough that we can't figure out what to do. Again, we have our equation, a times a plus b equals c squared. C is the length of the tangent portion, that would be 10. 2 is the portion on the outside of the secant, and x is the portion on the inside. So a is 2, b is x. We plug in what we know. 2 times 2 plus x equals 10 squared. And again, from there, we're just solving for x. So there's 2 ways to solve this equation. We can either divide both sides by 2 to start the problem, or we can distribute. And I think it's probably a better idea for you guys if we distribute, because a lot of you might make a mistake that would be regrettable if we don't distribute. So we'll do 10 squared, which is 100, and we'll distribute the 2, which gives us 4 plus 2x. That is a 2-step equation, which requires us to subtract 4 from each side, giving us that 2x equals 96, and then divide by 2, which gives us our answer, x equals 48. This is the other form. And basically, we're going to talk about 2 forms, 2 types of questions here. The first example was the first type. This is the second type. We're going to do 1 more of each type. Make sure you grab a screenshot if you want one, and then we'll be moving on to the next page. Again, it's the same equation every time. All we have to do is solve that equation, which has 2 different ways it could play out. Okay, here's our third example. Same deal. Our format is a times a plus b equals c. where C is the length of the tangent piece, A is the part of the secant on the outside, and B is the part of the secant on the inside. So that gives us 2 times 2 plus 70 equals x squared. So this is form 1 again. We're going to solve for x. So we combine the 2 and the 70 into 72. Then we multiply 2 times 72, which is 144. And then we take the square root of each side. So x is the square root of 144, or 12. Grab a screenshot if you want one. We have one example to go. One example to go. Okay, here it is, folks, your last example of the school year. Once again, we have our format. A times A plus B equals C squared. That is the equation we will use every single time that we have a secant and a tangent intersecting. A is 2, B is x, and C is 12. So we have 2 times 2 plus x equals 12 squared. We will distribute the 2 to give us 4 plus 2x, and we will go ahead and square 12 squared, which is 144. That is now a two-step equation, so we subtract 4 from each side of that equation, giving us 2x equals 140. And then we divide by 2, which gives us x equals 70. There you have it, ladies and gentlemen. We have completed all instruction for our geometry course. Once again, it's been a pleasure this year. Your assignment is going to be on Delta Math.